Remember, I said come today with questions. So we'll see where your questions are, where they lie. Let's first go ahead and check our evens. Our goal, we've got to get deep into section 4.6 today. So we're going to go quickly through 4.5. But slow me down if you have a question, okay? Number 4, vertical translation. Number 12, amplitude. There is a -1, but remember, always positive. Positive 1. Period, when you solved, was 3 pi. Get down the right answers. Probably not time to show all the work. Number 18, period is 20, amplitude is 2/3. But for period, you got to plug into the formula. Number 20, because of that little plus pi, there is, forget this little f with, I don't even know, typo. Put a little line through it. Forget that. There is a horizontal shift pi to the left. It's a plus. Pi to the left. It's a plus. Now 34 was a bit rough. Let me go ahead and zoom in on him just a little bit. You were supposed to graph 2 different ones. You could have graphed them all together. You could have also graphed them separately and then tried to compare. There were 2 different functions you were trying to graph and look at. One of them was f, and then another one was g, I think, right? These were our 2. You were trying to ask yourselves what is similar and what's different. They're both cosine, but which one is a flip? Which one is a vertical reflection?
G is that.
Good. G is going to be vertically flipped. F is going to be vertically stretched. So F is taller. F's waves are higher. And you guys could use all of their blah, 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 but you could also be doing just what I'm saying. So G is going to have a vertical reflection. F is going to be vertically stretched. They both have horizontal compressions. They both got shrunk from a normal one horizontally. This one got horizontally shrunk by a factor of 1/2, 1 over b. This one got horizontally shrunk by a factor of 1/4. If you went to go find your periods, this one 1/2 of 2 pi is going to complete every pi. This one 1/4 of 2 pi is going to complete every pi over 2. So long story short, the comparison between both of them, from this guy to that guy, this one's going to have to take this guy and vertically shrink him by a factor of 1/2, because he doesn't have the 2 in front. He's also going to have to flip him. And the period just got shrunk in half again. That's one way of saying it. If you were to look at the graph, you could also see it maybe a little bit clearer in the sense of G goes ahead and takes F and shrinks F. Not only vertically, but also shrinks it horizontally and it flips it. So shrinks it vertically, shrinks it horizontally, and it flips it. That's what's going on with the 2. Now guys, they like to write out all this extra stuff, like they actually like to tell or to write out to show every single key point, 1, 2, 3, 4, 5. I just let you guys show the key points, and that's okay. You don't have to actually write out all the X's and Y's at every key point, as long as you show them to me clearly. When it comes to a long answer of, say, like a quiz, same thing. You don't have to write out the X's and Y's. You just have to show them to me clearly. So once again, they write out all of the key points. My question is, could I have been able to tell that from your graph? Did you have a key point at 0, 0? Did you have a key point at half of pi over 4? At at pi over 8, 1. Did you have this point? I'll make you write it, but did you have it? Did you have a point at pi over 4, 0? Did you have a point at 3 pi over 8, negative 9? Did you have a point at pi over 2, 0? So, just in case you're wondering what you had to write down, did you have the points shown clearly? If not, then maybe you need to write them out. But if you have them shown clearly, that's enough, and that's okay. That's enough, and that's okay. 68 was a calculator one. Did you guys get the picture to show up in radian mode? Mm-hmm. Good. Not degrees. There's a pi over 3 in there, radians. Number 76. 76 was one of those funny look at a graph and pull out clues. Let me give you a second. Were you able to pull out the D, pull out the A? And if you had done it the way that I had shown you in class, you would have plugged it in. So did you figure out y is equal to -1 cosine of x minus 3? Does anybody figure out, because this, it's not an odd, it's an even side. Can anybody explain to me why the amplitude is negative if the height is upward, downward? Why is it negative? Yeah. If you look, they didn't allow for any sort of shift. Another way of writing this would have been -3 minus 1. There is no plus or minus on the inside. So this wasn't allowed to shift right or left. They said you got to start them right here. And guys, where does cosine normally start? On the top. So it's been reflected. It's starting on the top. There was no horizontal shift. Because this -3 was on the outside. It wasn't on the inside. D is on the outside. Just x is on the inside. So I had to start at the bottom. Yeah, I had to flip it. I had to flip it. 82 is another calculator one. But did anybody get confused by what they asked you to do on 82? Even though it was calculated? Oh, was 82 not in your assignment? Did anybody write down 82? You have it? Yeah. 82 is down there. 82. Where are they telling you to put these guys? In your grapher, right? Graph y1, graph y2. Chris, go ahead and move to the very back of your row with all your stuff. Thanks, buddy. y1 and y2, graph both of them. And guys, if we're trying to ask when the two are equal, what feature are you using in your calculator? Intersect. Good. So you're supposed to graph the two, use the intersect feature, and then you can find the two that they were asking for. They said only in between these two, which is why they made x-min and x-max. Intersect feature. Precalc graphing calculator handbook if you forget how to use the intersect feature. You can go back to your handbook. 86 and then 90, I think we're done. Let me give you a second to go and graph. Graph. Check. Great. What did you mark wrong? What questions do we have? Or what did CalChat not help you with last? 31. What else? 65. Right. Okay, let me start writing these down. 31, 65, 77. What else? Michael?
73.
73. Jacob? 18. Okay, can we go to 18 really quickly just because we already had him up here? Let's see if we can work backwards from what's going on. And then those odds. We'll get to in just a second. Kiddos, go ahead and look at those odds and see if you understood how to do them. Since we do have so many, I might get 4 of you up to the board to show me your work for it really quickly for some participation. So go ahead and check out those odds and see if you can do any of them. But meanwhile, number 18 is up here on the board. I would rewrite this, Jacob, as if we're going to do it like in our nice form with D's and A's. The question is, what's that pi over 10? And it's not a minus, so then it must be the b. Because there's no subtracting going on or even adding, so that whole thing, the pi and the 10, must be the b for my equation. So then when I go to do, probably amplitude made sense, you just stole the 2/3. But the period was the hard one. The period says take 2 pi over him. But remember, I think that's weird. Another way of thinking about it is take the pi over 10, and if you divide by him, you're multiplying by his reciprocal, which is why I say 1 over b, or flip it. And then maybe that makes a little more sense. But if you do use the 2 pi over b, just remember when you divide by a fraction, you're multiplying by, and that's where you get to the 2. Does that make sense? Yeah. So it does always look funny though, because you're used to b being right next to it. So a lot of people would just say b is pi. But you gotta take that 10 as well and say, no, he's a part of this too. He just can't be in the c over b, so he must be the other. Those of you guys that were checking out the odds on the board who worked on homework last night, does anybody think they could do one? Just show me, you don't have to explain it, just show me your work for it. They were hard? Alright, that's okay. Let's go ahead and peek at them real fast then. The book was worth a try. We're in section 4.5, yeah? Okay. Our first odd that I had was number 31. I think he was like that funny one that we were checking in homework that wasn't even. Well, that's not you guys. Hold on, I'm about to write in the other period's notes. They wouldn't be very happy with that. Let's go find yours guys' notes. Okay, as your notes are opening, here's number 31. Question, how many changes are happening in number 31? I know that that's kind of blocking part of it, but in number 31, how much is changing in our signs? What variable is that that's multiplied right before in our y equals d? You guys, hold on, we were doing this yesterday. A, right? Let's write up that formula. Who has it memorized? You should.
Y equals d plus a sine or cosine b parentheses x minus c over b.
Okay, so the only transformation we have is A, right? B is just normal, C over B is just normal, D is normal. Cool. All we have is A. A stands for what again? Amplitude. How high, how low? So question, how high, how low is this guy going to go? Oh. Okay, so if I was to graph this, now I'm going to have to graph it kind of zoomed in since I don't have a lot of space here. But if I was to graph it, doesn't sine normally go between like 0 and 2 pi? Isn't that normal sine? Normal sine, if you guys are in your notes, it's the very first sine curve that we ever graphed. Goes up 1, down 1, and goes over to 2 pi. So no horizontal change. It's still going to go to 2 pi, and it says 2 periods. I'll go to negative 2 pi also. But instead of going up 1, down 1, G, can I do different colors up here? Yeah, I can. G is going to go up 1, 2, 3, 4. And down 1, 2, 3, 4. But otherwise, I'm still going to have to go middle, top, middle, bottom, middle. I can go backwards. Bottom, middle, top, middle. And if you wanted to, you could have marked your negative pi, 3 pi over 2, pi over 2, positive pi over 2, positive pi, positive 3 pi over 2. But guys, for G, all you're going to do is instead of going up to 1 and down to negative 1, go up to 4 and down to negative 4. But what happens when we get to F? He's not going up 4, down 4. What's he doing? He's going, well, careful, he's still just going up 2, down 2, but what's the negative do? So instead of going up 2 first, he still starts at the 0, but instead of going up 2, he's going to go down 2. He's going the other direction. And he's only going to 2 and negative 2. But he starts going down instead of going up because he's been reflected. So I'm going to go backwards, follow the flow. If this is my wave, where am I going as I go backwards? Good. Follow your wave. There we go. That's number 31. Nice thing is there wasn't tons of transformations on 31. Some of these ones would have had a lot. 31, it was just going up 4, down 4. Otherwise, everything stays the same. Or going up 2, down 2, but I had to go the other direction to get it. That's number 31. 65, 73, and 77. They're all kind of grouped towards the end, but did that answer 31 okay? Okay. 65. Oops, that was way too fast. Not even close. Okay, hold on. There we go. Question, how much got changed on that guy? 65, you guys seeing him? Do we have a D? Ooh, we do. It's just been written funny. Yeah, negative 3 is our D. Good job. We do have a D. Question, do we have an A? Uh-oh, we have an A also. So our sinusoidal axis has changed. We have a vertical shift. Our amplitude has changed. What's our A in this one? 2. So it's been stretched by 2. Do we have a B? Oh, careful. Is there something next to the x? I know it's not outside yet, but do we have something multiplied by the x? Ah, we have a b. Do we have a c over b? Not yet. And why not yet? It hasn't been written nice yet, so let's go ahead and write it nice. Okay, I got it on a page so we can work with it. Anybody help me out with how to rewrite it? Where do we normally want to go first?
-3.
Yeah, let's do -3 plus. Now, here's what we got to think about. Factor out. Yeah, I need the b to come all the way out. I need x to be alone. Now, this is where it gets weird. If I factor out of 4, that's easy. C over b. So if you guys remember, we wrote down those two different versions of the formula. If it's bx minus c, I can make it b times x minus c over b. Boom. It's a little funny, but we have all our pieces, right? Okay, I'm going to go pretty fast. Because now that we have all our pieces, all of them pretty much just go straight into my graph, except, what's the one that I have to use to find with a formula or something else? Phase shift, we could use our trick to get the initial point. You're right. We could use our trick to say, hey, is this sine or cosine? Sine. Okay, so sine's y value for its initial. Where does that always start? Middle. And what is the middle? Which one of these? And in your notes you wrote sine is y equals d. You might not have remembered that, but sine starts in the middle, and the middle is the sinusoidal axis. Okay, that's kind of a formula. The one I was thinking about was this guy. Don't I have to find him? Yes. Using which piece? Good. Using the period. Sorry, using the horizontal dilation. So I do 2 pi over, which will be pi over 2. The only other thing that might be good to have whenever we do period, in order to do our key points, we got to cut our period into fourths. So that little quarter cycle will help us with the tick marks. The quarter cycles will be every 1/4 of that, which will be pi over 8. Pi over 2 times 1/4. It's pi over 8. Now, there you go. Here's -3, here's -1, here's -5. Anybody know why I labeled those guys? Yeah, -3 is right there. Why did I label -1 and -5? Here, you're fine. It's amplitude. I'm going up 2 and down 2. So up 2 to -1, down 2 to -5. These are my handwriting lines, right guys? I need my initial point. Wait, I know him. Pi over 4. So if I was just to not be thinking, and just like randomly put down a pi over 4 and say whatever, there he is, I could mark a point right here. But question, what do I want my tick marks to be? According to this over here, do I want my tick marks to be pi over 4s?
No.
What do I want my tick marks to be?
Pi over 8.
So I'm going to go ahead and say, oh, wait, I need a pi over 8. So I'll keep on going by pi over 8. So that'll be 3 pi over 8. 1 pi over 8, 2 pi over 8 reduces 3 pi over 8, 4 pi over 8, 5 pi over 8. Why am I putting so many? I need, oh, maybe that'll be enough. Let's do one more just in case. That would be 6 pi over 8, which is 3 pi over 2. I need so many because I need to go ahead and go over and up. It's a sine curve. Over and down. Over and down. Aha, I did need that last one, didn't I? And then back up. Yeah. You get all your pieces organized first. Get your graph all set up, then you just have to go ahead and swoop it. There it is. Follow the flow. Now, why did I go up instead of down? So we just went down a second ago. Just a normal sine curve. Just a normal sine curve. That was number 65. 73 and 77, I think both of them were looking at graphs. Those of you guys with those questions, can you peek at it real fast? Oh, 73 was. 73 was. I'm just going to do it right here in the book real fast. How high does this wave go? 3. Okay. How low does this wave go? -1. Okay. So if it goes between 3 and -1, that's my upper and lower. Question. First of all, what's my amplitude? Can you guys tell? 2. Up 2, down 2. So where's the middle? Amplitude is 2. Yeah. D, which is the middle, is going to be at 1. Go up 2, down 2. It meets at 1. So D is 1. What else do I need? It says cosine. Uh-oh, I have to start at the top. Oh, wait. Isn't it at the top at 0? Okay, so I can just say C over B. Oh, they didn't even say look for a C over B. Okay, well, whatever. C over B would be 0. My initial point would be 0. And then the period, if you guys look at it, is counting by half pies. So if I go from, the best way to count it would probably be here to here. This would have all 5 of my points. There's 1, 2, 3, 4, 5. That's 1 whole pi. 1 whole pi is 2 pi. But the nice thing is, they already told me, guess what? There's no period change because they didn't let me have a B. And there's no horizontal shift because they didn't let me have a C over B. So I'm like, okay, whatever. My A is 2. And my D is 1. Dun, 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 dun. It's a little weird because it didn't show all the letters. But if you wanted to, you could have used that equation. You could have just plugged in C over B is 0 and plugged in B is 1 because the period didn't change. You could have used either equation. They just tried to help you by saying there's only been 2 changes to the graph. Last but not least, number 77. Oh, he was a graph. He was a gnarly one. Question, how high, how low does he go? Good, 3 and -3, so A is 3. Question, where's the middle?
0.
Yeah, because it's centered around this. Okay, so no shift. Who am I supposed to be doing? Sine. Sine starts in the middle. Oh, this one does start in the middle at 0. Look. No shift, so I can say C over B is 0, but does it start by going down or going up? Down. So I'm going to have to go ahead and make A for plugging in. I have to make it a negative to reflect my sign, to have it go down. Huh. The last piece I need is, well, you could think C, but if we're plugging into that formula, we're missing the B. Where does B come from? The period. Period I have to set equal to 2 pi over B so I can solve for B, but I need to know period, and what does period stand for? What's the term period? 1 cycle completing. So if I go, there's 1, 2, 3, 4, 5. How long did it take to complete 1 full cycle? I think isn't pi that guy? Yeah, I think it's just pi. So if, any mental mathers out there? If the period is pi, what must B have been? 2. Yeah, so B is 2. If you wanted to, you could solve it. B times pi equals 2 pi divided B is 2. Now, what are you going to do with that? Plug it in. So if I come over here and plug it in, guys, help me out. Just give me the numbers real fast. What's D? 0. 0. What's A?
-3.
-3. Sine. What's B?
2.
And what's C over B? 0. How'd they want me to write this thing? With the B inside or outside? Inside. Ah, yeah, that formula they gave me inside. So y equals -3 sine of 2x, well, minus 0. Now, section 4.6. Section 4.5, what 2 types of functions were we graphing? Sines and cosines. Sinusoidal curves, they're waves, right? Okay. Section 4.6, you might not remember, but section 4.6, yesterday I said, we've talked about sine, cosine. How many other trig are there? 4. Okay, so what's examples of the other 4? Tangent and cotangent. Guess what? Those will be very similar. But then also, secant and cosecant. Yesterday I said, if you can get down sines and cosines, you'll be able to do secants and cosecants. Let me show you how. At least one person per group, grab out a calculator. One person per group. We're going to use this guy right here. Any groups, raise your hand real fast if no one has a calculator. Oh, wait, there is. Any groups not have a calculator, choose one. This one else you can see it. Mini field trip, do your stuff. Okay. Hey, Josh. You're half the reason he's back there. Okay, coming back. Calculators. If I wanted you, we're going to do a little discovery just for a moment. This is a sine curve, right? And it looks like that guy, number 77, true? Okay. What if I wanted you to graph in your calculators to see what he looks like, -3 cosecant of 2x? Is there a cosecant button? You should know this. No. But what does cosecant equal?
1 over.
1 over who?
The entire. No, not that.
The entire equation of sine. You could write -3 cosecant of 2x as -3. Well, if you guys want, you can put -3 over. Be in radian mode. Remember, degree mode is super hard to trick to get it on a window without zoom trick.
Oh my god.
Whoa.
I want you to graph -3 over sine of 2x.
I'm so
What?
Okay, coming back.
Another day in paradise.
Okay, I need you to change your window a little bit because most of you are in Zoom Standard. So pause, change your window a little bit. Look at this guy. I want your, help him out, whoever has a calculator in case it gets stuck. I want your, good, be in radian. I want your x min. Oh, wait, x min, where do I want you to be right now? X min, x max, y min, y max, where am I?
Window.
Window, go to the window button.
Wait, we have like 3 calculators. Oh.
god.
Okay,
Which is hers?
be in radian mode. We'll problem solve in a second. I need at least one calculator though, in the window. X min, I want you to make it -2 pi.
Oh, 2
You can actually type in the pi. Calculator knows it. Go find the pi. -2 pi.
It's
X max, make it 2 pi. Because this graph has -2 pi and 2 pi. Y min, I want you to make it -6. And Y max +6. That's not exactly what this graph shows, but there's a reason. And then graph. X min -2 pi, X max +2 pi.
What's going on?
Y min -6, Y max +6.
Okay, you got that water in the back?
Now guys, wait. My question, do you see little like parabolas that are like up and down?
Mine did it in invisible, so I'm not getting any better right now.
Do you see little parabolas? Wait, are you in radian mode?
Yeah.
Check number 1. Check number 2, did you put in -3 over sine of 2x?
Yeah, I am in radio.
Cool, and then do you have like up and down and up and down and up and down?
Yeah.
I think
Okay.
so.
Now, the weird thing is, guys, do you see how there's a big old gap in between them?
Yeah.
Go back to your y equals. I want you to graph in y2 the sine function. Just the normal, original, -3 sine of 2x. I want you to graph -3 sine of 2x.
Hey, watch your language. I know.
Yeah.
What if it's just... Don't even say God. Okay?
Okay, here's my question. Here's my question. Can you see? All right. Can you see how cosecant bounces off of sine? Let me show you what's going on. Ready? Whenever the sine hits the x-axis, aren't those called the zeros of the function? Okay. What would happen if I was to take over 0? Cosecant flips it. What would be 1 over 0? Undefined. AKA, at all of the zeros of a sine or cosine, for the cosecant or secant, they're going to be vertical asymptotes. And then, question. At the highs and the lows, the maximums and the minimums of a function, of a sine or a cosine, before it's transformed, sine and cosine goes up to 1 and down to -1, right? What would happen if we flip 1 and flip -1? Any change? What's 1 over 1? 1. Okay, what's 1 over -1? They're going to stay the same. And that's going to happen even after you stretch at all the peaks and all the valleys, all the maximums and all the minimums. The cosecants are going to match or hit or touch the sines. At all the maximums and minimums, the secants will always hit the cosines. And then what happens in between the vertical asymptote is cosecant, this is a sine curve. Cosecant comes in and bounces off. 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 Okay. So I just told you how to make a cosecant curve. And guess what? It's the same way of making a secant curve with a cosine function. I'll write some notes on it, but basically what it is take all the intercepts, make vertical asymptotes, meet at all the maxes and mins, and bounce. Done. What's hard about secants and cosecants? You have to start with the sines or cosines. Without the sines or cosines, what do you bounce off of? Where do you make your vertical asymptotes? Where do you make your maximums and minimums? So section 4.5 is super important for graphing sines and cosines, but what else is going to be super important for? Secants and cosecants. So really, by learning 4.5, you just learned 4 out of 6 of the trig functions. We only have 2 left. Let's take some notes though for tangent and cotangent. Ready? Notes open, section 4.6, tangent and cotangent. We gotta talk about them because they're different, they're unique. They're different, they're unique. I'm gonna go ahead and dual page because yesterday you guys didn't get a lot of notes down.
Because nobody has ever done it before. I guarantee you I'm the first person.
Okay, let's focus on it. Tangents and cotangents, they're different. We've spent a lot of time on sines and cosines, which is going to help us with cosecants and secants. But tangents and cotangents, we got to talk about. Alright guys, all talking cease. All talking cease. It's time to zero in because this is new. Secants and cosecants will be using what we've already done. Tangents and cotangents are new. New as far as graphing. They're very similar to each other. If we can learn tangents really well, cotangents should follow. But we've got to get down these ones because they're new and different. Take a second to set up your notes, okay? Anytime there is a blank space, you can pretty much just skip one line, like the period, domain, range, symmetry. But over here, I want you to skip 2 lines.
I was talking about under tangent from vertical asymptote. What is it?
4 plus pi times n. Yeah. We'll talk about today, but it's basically adding multiples of pi. So adding 1 pi, another pi, another pi, another pi. Multiples of pi. I'm going to turn the page in 1 second because we're actually going to get down tangent and cotangent before I talk through because they are very similar. I want to show you how similar they are as far as the setup. So get to this example over here. If you want to draw like for the graph, you can. You might want to skip a couple lines for the work you're going to do. Maybe just one extra line. That should be good. You should be getting pretty close for me to go forward one page. Maybe not 2 pages, but at least 1 page. Maybe I'll still on the first page. Let me go forward one. And cotangent, you see, it's super similar. Tangent and cotangent, super similar. Their actual pieces will be a little bit different, a little bit off. Kind of like sine, cosine, there's a shifting that happens. But still super similar. Good job, guys. Good focus. Anybody still on the, I guess it's technically the second page, anybody still on the graphing for tangent? Okay. Good job, guys. Do the same thing, skip 2 lines for the vertical aspect. I don't know if you need to, but skip 1 line after the example. Is there a question? Sorry, I missed it. Okay. As you guys have been learning, hopefully you've been seeing vertical asymptotes. That's one of the most important parts, really, of all the 4 functions in 4.6. Because as you notice with the cosecant secant, it separates the bouncing off. It separates the bouncing off. In tangent and cotangent, it's going to separate the cycles as well. Or the cycles. The cycles as well. So the vertical asymptotes help us get our bearings. In sine and cosine, The sinusoidal axis and amplitude help us get our bearings in the sense of, okay, this is where we're going to be, this is where we're going. But sine and cosine, they're waves that go on forever. There is no breaking up on the, or with the x-axis. But for tangent and cotangent, secant and cosecant, there's breaking up along the x-axis. It's going to separate each of these pieces. So vertical asymptotes are one of the most important pieces to find for tangent and cotangent, and really the rest of the trig function. So let's go ahead and go back to tangent. Hopefully you have it mostly set up, ready to go. We talked about yesterday, tangent comes from a fraction. Tangent comes from y over x. And so since he comes from a fraction, then he could have a denominator that's equal to 0, hence where the vertical asymptotes are even a possibility. And if you guys think about all the formulas for the other 4 trigs, every single one, tangent, y over x, cotangent, x over y, cosecant, 1 over y, secant, 1 over x, all of them have denominators, and each of those denominators can equal zeros at different places on the unit circle. And so they're going to be vertical asymptotes. Now tangent has its vertical asymptotes at pi over 2, starting there, and then every time, or every measure of pi away from that. Now, I've made my tick marks 1/2 pi, so I'm going to have to go 2 tick marks to get to another vertical asymptote, or 2 tick marks to get to another vertical asymptote. You can keep on doing that. Without any transformations, vertical asymptotes will happen at pi over 2, and this little pi n, Nick was asking earlier, this is for all integers, or all positive or negative whole numbers. So it could be 1 pi, 2 pi, 3 pi, 4 pi. You could be adding 1 pi, adding another pi, adding another pi. It's just saying it's going to repeat over and over and over and over. Period. If tangent repeats every pi, that is the period, which is different than sine and cosine. Now guys, hold on. You have cotangent written down, right? Do the exact same thing for cotangents, period. Its vertical asymptotes will be different. But cotangent's period will be the exact same. Tangent and cotangent both repeat in half as much time as sine and cosine. So tangent and cotangent both have periods of pi. Domain for tangent, x is just not going to be allowed to equal any of the vertical asymptotes. All the x's are fine except for all the vertical asymptotes. So all these pi over 2 plus pi n, pi over 2, 3 pi over 2, 5 pi over 2, 7 pi over 2, all of those are going to be illegal. All of those are going to be left out of the domain. But the range, if you guys look at it, how low does this guy go? Yeah, negative infinity. And how high does he go? So the range is going to be all real numbers. And guess what? Cotangent is the exact same thing. We haven't found his vertical asymptotes yet. But for cotangent, the domain is going to be everything but his vertical asymptotes once we find him. And the range is going to be forever low, forever high. Symmetry. Can you guys tell? If you were just, it gets confusing when you repeat over and over again. Just look at this one cycle. Can you tell what kind of symmetry it has? Origin. Good. Not y-axis, not x-axis, but origin. Good. So origin symmetry, or we could also call that, do you remember that other word that describes origin symmetry? It's not even. It's on. And guess what? Cotangent has the exact same symmetry. The only difference between the two, well, one of the main differences is the vertical asymptotes. Bless you. The other main difference is as one goes up, the other goes down. Now let me go ahead and show you how to do a transform tangent function, but let me give you a hint as to where to start. If vertical asymptotes are so stinking important, and if they come from x values, vertical asymptotes say, look right here at the argument. Look at what is inside the tangent. Take all of that. Take the dx minus c, or take the entire argument of tangent. Take the entire argument of tangent. Take all of the stuff that's inside tangent and set it not equal to. What do you set equal to? That's the thing. We're finding the vertical asymptotes. set it equal to what the vertical asymptotes are that we just wrote down in our table. And then you're going to basically solve for x. So you're going to take the argument, set it equal to that expression for vertical asymptotes, and solve for x. So in this example, take what's inside tangent, x over 2. For the vertical asymptotes, when you take x over 2, set it equal to pi over 2 plus pi n. How are we going to solve for x? Algebraically, how do we get x alone? Yeah, multiply both sides by 2, but what we do to one side, we got to do to the other. We're going to have to distribute that 2, and we end up with x is equal to, that'll just be pi, and this will be 2 pi n. Which means, starting at pi and going 2 pi away, we're going to have our vertical asymptotes. And guys, I don't spend a lot of time on tangent or cotangent, because what I tell you is once you have your vertical asymptotes, just go halfway in between. It'll always be your point of inflection. And if there's a vertical shift, maybe you'll have to move that point of inflection up or down that middle point. But otherwise, concave down before, concave down after, as long as it's not been flipped. And for me, to be honest, I'm happy if you get that. Tangent, there you go. And if you were to graph it on your graphing calculator, you would see these little cycles over and over again, separated by vertical asymptotes. So, tomorrow, I have this homework 4.6 due on Friday. It would be a good idea to start it tonight, but I would say, you know what, you're probably going to have to focus on Precalc tomorrow night, not tonight. Sound good? Tomorrow we're going to talk about cotangent and cosecant, secant, bouncing, but we'll be able to get it pretty quickly. Just give me a little more time tomorrow. Bye, guys. You work on other classes a little bit more tonight. Save time and everything else tomorrow night.
I'm Steve.
Bye, everybody. Happy Wednesday. Thanks for that focus. It was good today.
So this kid's last for teammate, they didn't get a penalty. Okay. And then he tripped him, and then the ref's arm went up to show that man is going to get a penalty. And I was like, and I was just smacking on the board. And this kid, he's 5'3", and he just skates on past the bench. He puts his arm up here and he gets his face.
Are you serious? Oh my gosh. One of the kids
Yeah, the kid was like 5'3", so he had to put his arm up here.
Did you do anything after?
No, I just looked at that and I was like,
oh man, seriously.
See you, Prince.